Today's video is looking at the place value of decimal numbers and then using that knowledge to compare decimal numbers to see which one's bigger or smaller. I've got a typical place value table here for you to have a look at, and some numbers over on the left hand side which we are going to be comparing to see which one is biggest. We know that the numbers that are furthest to the left are quite large on the place value table, and the ones that are to the right are getting smaller. Keeping that in mind, let's have a look at what happens when we put a 0.08 and a 0.2 into the place value table. Remember that we're trying to work out which one is bigger, which one is smaller. 8 does look like it's much bigger than 2, but of course it all depends on the column or the place value that that number is in. In this case, we can see that the 8 is in the hundredths column and the 2 is in the tenths column, and we know that tenths are much bigger than hundredths, so 0.2 is clearly bigger. What we could also do is add a 0 into this position here. It doesn't change the value of 0.2, but it does show us that we are comparing a number with 2 decimal places here with another number that's got 2 decimal places here, and makes it a little easier for us to compare. We're comparing 8 hundredths with 20 hundredths, and we can see quite clearly from that that 0.2 or 0.20 is bigger. So we could write that in a comparison statement over at the side. When I'm comparing 0.08 with 0.2, we can see that the 0.2 is clearly bigger. Using this same idea with the second example down the bottom here, 1.59 compared with 1.509. At first glance you might think that 509 is bigger than the 59 above it, but again, let's fill in that space with 0. We now have 590 thousandths compared with 509 thousandths. We know which one is bigger. It's the first one, so I would be writing this as 1.59 is greater than 1.509. Okay, so another way of looking at this is by making sure that the numbers we're comparing have the same number of decimal places, or numbers after the decimal point. So 0.08 has 2 decimal places, 0.2 only has 1 decimal place, but we can add a 0 to the end of this to make it 0.20 without changing the value of the number at all. So now we're comparing 0.08 with 0.20, and clearly 0.08 is less than 0.2, so we can have that comparison statement. You've just seen me add some zeros to some numbers, and I guess my question is there such a thing as an unnecessary 0, or a 0 that we can leave out? So I'm going to pose this question to you. What about James Bond? We know that he's Agent 007. We could quite easily leave off these 2 zeros and he would still be Agent number 7. So in this case the zeros are what I would call unnecessary, although 007 does sound a little bit more sophisticated. The 7 is in the units column, whether or not we leave these zeros there. Let's look at some other examples. 3,500, we can't just leave off those zeros and say it's the same as 35. So clearly those zeros are very important. They would be what we call necessary zeros. The next one, 5.00, these zeros here are unnecessary zeros. You might like to think about the idea of $5 as being written like that, or 5.00. They both mean the same things. We can leave the zeros off and we do not change the value of that amount. The next example here, we've got a 0 on the end here. My question is, if we leave it off, does it change the value of that number? Well, you can see that we can leave it off. We still have a 3 in the units column, a 4 in the tenths, and an 8 in the hundredths. So by leaving off that 0, we have not changed the value of that number. Our next one, 1.609, if I leave this 0 out here, then I end up with a very different number, 1.69. So this 0 here is very important. We can't leave it out. It creates a space, it provides a space between the tenths and the thousandths, and For that reason, if we leave it out, we get a number here that says 6/10 and 9/100 instead of 6/10 and 9,000. The last example over here, 0.08, we certainly can't leave those zeros off. These zeros are necessary. They make it clear that the 8 is living in the hundredths column, and if I leave any of those zeros out, it becomes just an 8 in the units column. So as you can see, some zeros we need to keep, they are like spaces in braces, and we need to keep them there so that the rest of the numbers, or the teeth, remain in the correct place. One of the other things we're going to look at today is how to expand a number, writing it using expanded notation. The number 491 in our first example, if I'm going to expand that, it really means writing it out, breaking it up into its parts. We've got 4 lots of hundreds, we've got 9 lots of tens, and we've got 1 lots of units, as you can see here. So there's nothing too unusual coming on here. We can, however, use this idea with our decimal numbers as well. So 5.209 we know is the same as 5 lots of units. There's a 2 in the tenths column here, so that's 2 lots of 1/10. We've got nothing in the hundredths column, so I don't need to write anything down about that. But we do have a 9 in the thousandths column, and that's how we write it, 9 lots of 1,000. Alright, now you've got enough information to complete the work related to exercise 6A that's on your unit planner. That's what you'll be doing in your next class. Before then, of course, you need to finish your whisk for this video, so get to it.